Hello everyone, and welcome to lesson 3 on properties of whole numbers. My name is Melissa Lieberman and I'm the in-house maths teacher here at ICS Learn. My contact details are there on the screen. I go through these every time, so if you ever need to get in touch with me for help with anything, then you can phone me. That number should be more or less at my desk between 9 and 5 during office hours, or just email me mathsteacher@icslearn.co.uk. So today we're going to look at properties of whole numbers. Last lesson, if you watched either the recording or joined me live, we looked at some whole number calculations, and we also we did some examples of negative numbers, negative integers, and BODMAS or BIDMAS. Now, one thing to stress is these early lessons might seem to cover a lot of things very quickly, but anything that's important will be revisited and extended on. So bear in mind that someone starting maths, GCSE, has been doing maths at school for 10 years, so they already know a lot of math stuff. So if it seems a little rushed or the textbook is too difficult, just learn at your own pace. For some students, this will be maybe too advanced, and for other students, it will be a little too easy. So I'm going to give you options to work through in a way that's right for you. Some people might take a week really studying this content and making sure they know it really well. Other people might just spend an hour and move on to the next thing. Please don't ever spend more than 1 week on one of these lessons, because anything that's important will be revisited later on. Okay, this lesson will last about 1 hour, and I'm recording it, so if you're watching live and you want to watch any bit of it again, you'll have access to the recording afterwards. Now, I always say this because I think it's important as you're watching to make notes. If you're watching live, you won't be able to write everything down because it will go a bit too quickly, but you can always watch back later on. If you're watching the recorded version, a big advantage to not being in a classroom with a teacher is you can actually pause it, write things down, make your own notes, because that will make it easier for you to revise later on. And part of the learning process is a part of a way of engaging with the things that you're seeing on the slides and making notes. You don't have to copy down what you're seeing on the slides word for word, just the key points, and do it in a way that's useful to you. If you like using colours, use colours, take your time, make it nice and neat, and then you've got your own revision guide to help you at the end of the course when you need to revise for your exams. Now, I occasionally use a calculator. Today I've got a few things that I want to show you using this Casio calculator, so if you've got it to hand, use it. If not, don't worry about it too much. So first of all, I hope everyone watched last lesson and had a go at the questions in the calculations chapter in the textbook. I got a lot of emails, people finding it really hard. Don't worry if you know some of this is a little bit advanced. Before I start today's lesson, I just want to make a few points about how the textbook works. So I'm just going to share my desktop a moment and share this chapter with you, just to show you, if you're working through closely with the textbook, how that works. So let me just share my desktop. The screen will just flash lightly, and I'll open that up. So hopefully people watching, you've found the textbook, you know how to set it up. If you're having troubles with that, let me know, but the link is on your main course page under Student Course Resources. You click on the link next to the green jigsaw piece, and this will be a good source of further worked examples and questions. So let me just share this chapter with you. Just give me a second, the screen will flash as I show my desktop, and hopefully it will come up as well it should come up on the recorded version. So I've magnified this quite a bit, but what I wanted to go through was, when you start each chapter, there's a section here that says before you start. Now, this is supposed to be things that in theory you would have done before. KS3 means Key Stage 3, and in the UK, if you go to secondary school in the UK, that is the stage before GCSE Maths. So these warm-up questions, if you like, are there to say these are things that you should already know, but remember, this book is written for people who are at school or college and have just done maths. If you're an adult learner and haven't done maths in a very long time, I just want to say, please don't panic if you can't do these warm-up questions, because I mean, the answers are in the answer book, so if you want to look them up, you can do them in the answer book. But it's just a little warm-up to see what can you do already. If you can't do them, don't worry, because they'll be repeated in the chapter if they're important. So that's an important point to make. If it refers back to previous chapters in the textbook, then you can look back at previous chapters in the textbook. But if it says Key Stage 3, I have recommended a Key Stage 3 textbook that you can buy if you want to. Key Stage 3 really will cover most things up to a GCSE Old Grade C. So if you want to work through a Key Stage book in the initial stages as you warm up to the course, that's fine if you feel that you need to plug gaps in your basic maths knowledge. It will still be very useful for GCSE. The next thing I want to show you is every chapter in the book. So if you're working through the textbook, be aware that every chapter starts with this launch pad. And the way that this launch pad works is to check your previous knowledge. So if you've done this topic before, so if you can do all of question 1 very easily, work all of these things out without using a calculator, then tick. There's a little tick box there, then you can go on to the next step. You don't need to do section 1 basic calculations. Go through step 2. If you can do all of step 2, tick, you can go on to step 3. If you can't do step 2, then you go on to section 2. So in this way you can see what point you're at. So if you can already answer all of these questions quite easily, then you don't need to do section 2. If you can answer these questions in step 3 quite easily, then you can just go straight to the chapter review. So if you've studied GCSE Maths quite recently, or if you're planning to sit higher tier and a lot of the things in the foundation tier book are things you've done before and you're confident with, then you can skip all of the sections and go straight to the chapter review. So that's what that launch pad is for. It's to assess what you might already know and what bits you could potentially leave out or not spend too much time on. The chapter review at the end of each chapter just gives you some revision questions that cover the whole of the chapter. Now, my lessons don't cover the content in the textbook in the same order at all, so I jump around and use different bits at different times, and at the end of each of my lessons I'll tell you which bits to do. But if this book is too hard, I'm just going to stop sharing my desktop for a minute. If this book you're finding difficult because it does assume a lot of Key Stage 3 knowledge, then you can buy one of these books. I'm linking you here to the Foundation Tier CGP workbook, which is very good. You can pick these up for not very much if you buy used versions on Amazon. So if the textbook is too hard, don't use the textbook, use these instead. CGP Key Stage 3 Maths will cover most of the content for Unit 1 and Unit 2 lessons. And if this is too easy and you just want to do higher tier, skip over the Unit 1 lessons and just go straight on to the next unit using the recordings. That's absolutely fine. You don't have to work through every lesson. Work at the level that's right for you. Alessandra, you just bought the first one. That's good. It's just a bit easier than the textbook. If you want to have a really good grade and do really well, work through the textbook. But if you're finding it too hard and you maybe, you want to work up to the textbook, use those books. Okay, I digress. Now, this is what I'm going to be covering today. Types of number. Now, here I'm just going to define all of the things that the keywords: primes, factors, multiples, square numbers, cube numbers, factors, multiples, and so on. So I'm going to give you all of those important definitions. First bit of the lesson is going to feel like a bit of a dictionary lesson. I'm going to cover square and cube numbers, which hopefully you've met before. The opposite of squaring and cubing numbers, which is finding the roots. I'm going to throw in some negative numbers work in there as well, just to practice what we did last lesson. Then I'm going to also cover multiples, primes and factors. Factors, multiples and primes. This is a topic that I will go on again in more detail at the start of Unit 2. So it's just an introduction. So we're not going to do it in any great depth, just the basics of how to find multiples and factors and how to write numbers as a product of prime factors. 3 words that we're going to learn about: product, prime and factors. You will get used to these as you go through, but it's very important to learn the language of math so that when I'm going through the course, when I say factorize this, you don't think, oh, I can't remember what a factor is. It's important that you learn this language right at the start. So the keywords are written in pink. If you're watching live, don't worry too much about writing all of this down. If you're a slow writer, you can watch it back later and make notes then. So first of all, this is a word that we met last time. An integer is just a whole number, which can be positive or negative, or 0. 0 is also an integer. So often they talk about integers when they're talking about negative numbers, but it's a whole number. So no fractions, no decimals, just whole numbers. So in this lesson, when we're talking about primes, factors and multiples, we're really talking about whole numbers. We're not considering any fractions or decimals. There's plenty of time to do those later on. Now, hopefully you know what an odd number is. An odd number is a whole number that can't be divided by 2. So it's every other number starting with 1. So you've got 1, 3, 5, 7, 9, 11, and so on. They're called odd numbers. They come up all the time, even at A-level maths. You may be surprised to think, so this is not trivial. Then you've got even numbers. So even numbers are just numbers in the 2 times table: 2, 4, 6, 8. Any even number ends in either a 0, a 2, a 4, an 8. I think I've said them all now. Have I missed any out? I don't know if I said 6. But it will end in in an even digit. So if you've got a really, really big number, 572,974, then it's an even number. So all we have to do to work out whether a number is even or odd, for that matter, is look at the last digit. Now a square number. I'm going to go into this in a lot more detail in a minute, but just so you know what a square number is. Now a square number is a whole number, which, now it says there that the product, remember we met that word last lesson, product means multiply two numbers together. So when you multiply a number by itself, 2 times 2, 3 times 3, 4 times 4, 5 times 5, the outcome of that is called a square number. So 25 is a square number. 81 is a square number because that's 9 times 9. 100 is a square number because that's 10 times 10. So these square numbers come up all the time in maths and in whole number theory. So we need to know what a square number is. You're going to need to learn the first 15 square numbers, which I'll show you in a moment. And you also need to know how to do the reverse of squaring a number, which is square rooting a number. And I'll go through that in a minute. So that's the definition of a square number. The smallest square number is 1, because 1 times 1 is 1. Okay, we'll go through in a moment. Now a cube number happens when you multiply a number by itself and by itself again. So, for example, 2 cubed is 2 times 2 times 2. Now that's sometimes called 2 to the power of 3 and is written 2 with a little 3 above it. So it just means, and it's different from 2 times 3, so be careful. So 2 times 2 times 2, this is read as 2 cubed. So when I see this 2 with a little 3, like that, I say that means 2 cubed, or 2 to the power of 3. Because it's the way you work out the volume of a cube, because you go 2 along, 2 across, and 2 up. And that's 8. So 8 is a cube number. So that the number that results from multiplying a number by itself, and by itself again, and by itself 3 times, will give you a cube number. So 10 cubed is 10 times 10 times 10. 10 times 10, 100, times 10 again is 1,000. So 1,000 is a cube number. I'll go into more detail on this in a moment. Now, we also have the idea of a root, and a root is what number do you multiply by itself to get that number. So if you've not done square roots before, it will take a little bit of practice. Now, 5 squared, 5 times 5 is 25. But if I ask you for the square root of 25, what I'm asking you is what number multiplied by itself gives me the number 25. So that means that the square root of 25 is 5. So it's the other way around, and that's called a square root. But we also have something called a cube root. And the way we show the difference between a square root and a cube root is there's a little 3 just there above the root symbol. So a cube root just means what number do I multiply by itself and by itself again to get that number. So we just learned that 8 is 2 times 2 times 2, or 2 to the power of 3, or 2 cubed. So the cube root of 8 is 3. So it just does the opposite thing. Now, if you're new to this, we'll do lots of examples, so don't worry too much. I'm just defining it. Now, we're also going to learn today about factors. Now, another word for a factor is a divisor. And sometimes a divisor is an easier way of remembering it. It's a number that goes into another number. So a factor of 10 is, well, I've talked too much, so you tell me what a factor of 10 is. So when I say what is a factor of 10, what I'm asking you is what is any number that divides into 10 exactly without leaving a remainder. So those of you watching live, wake up. I've been talking too much. Okay, so Alessandro, 2, 5, 10, good. 5, well, 5 is definitely a factor because 5 goes into 10 twice. And if 5 goes into 10 twice, then that means that 2 is also a factor. You'll find that factors often go in pairs. 10, that's correct. 10 goes into 10 once. And because 10 goes into 10 once, 1 is also a factor. So think of them in pairs. We've got 1 and 10, and then we've got 2 and 5. There aren't any others. Yep, and 1 as well. That's right. 1 is a factor of every whole number. It divides exactly into every whole number, and every number can be divided by itself and 1. If those are the only factors, then the number is prime. But we'll go on to that in a minute. And this is the instruction. So anyway, factors go in pairs, and we'll look at that in more detail in a moment. So just remember, a factor is a number that divides into another number exactly without leaving a remainder. Then we've got a multiple. kind of the opposite of a factor. So where a factor is a number that divides into a number, a multiple is the result of multiplying a whole number by another whole number. And we can talk about multiples of 3, for example. So multiples of 3 are just numbers that are in the 3 times table. So the result of 1 times 3, 2 times 3, 4 times 3, 5 times 3. So 3, 6, 9, 12, 300, 3,999. Any number that has 3 as a factor, any number that can be divided by 3 exactly, is a multiple of 3. I mean, you can have multiples of any whole number. Remember, for all of these definitions, we're talking specifically about integers whole numbers. So multiples of 4 are 4 or 16 or 40 or 80 or 400, any number that can be divided by 4. That's quite an easy idea, I think. So we've got multiples. Just a few more definitions, and then we'll go into the actual questions. Now, common factor. You know what a factor is? It's a number that divides into another number exactly. But a common factor is when you have 2 or more numbers, and you look at common just means that they share it. So if 2 numbers share a factor, then they have a common factor. So any 2 even numbers will have a common factor of 2 because they both have 2 as a factor. One is a common factor of all numbers, as we briefly mentioned in a moment ago. So if I had 80 and 90, a common factor would be 10 because 10 divides into both of those numbers. And it's an idea that will come up throughout the course. For example, if you're cancelling fractions, for example, you divide by a common factor. If you're doing it right, you're dividing by the highest common factor, but we'll go back to those as throughout the course. The word factor is used a lot. Here's a couple of examples. So the factors, for example, of 6 are 1, 2, 3, and 6. Factors of 15, numbers that divide exactly into 15. Yes, it provides also a common factor of 80 and 90, but 10 is the highest common factor. So you can have common factors, and then you can have the highest common factor, which we're going to talk about in more detail later in this lesson. So if you were asked to find the common factor of 2 numbers, the easiest way to do it is to just write all the factors of both numbers and then find the ones that are in both lists. Again, I'm going to go through this in more detail in a moment. Now, a common multiple in a similar way is a multiple that's shared by 2 or more numbers. So the common multiple is always going to be much bigger than the 2 numbers. So for example, if we were asked for a common multiple of 2 and 3, multiples of 2 are 2, 4, 6, 8, and so on. Multiples of 3 are 3, 6, 9. 6 and 12 are both common multiples of 2 and 3 because 2 and 3 divide into the factors of 6 and 12. Okay, so the factors and multiples are very closely related, so be careful not to mix them up. So you just remember which one multiples are, and factors are divisors, so remember it that way. And then I think this is the last thing that I wanted to define, and that's a prime number. Now, a prime number, you have to be very clear about our definition, is any number greater than 1. Now, we have to say any number greater than 1 because 1 is not a prime number. So it's one of these quirky numbers that doesn't quite fit the rule. Sometimes it's defined as any number that has exactly 2 factors, 1 and the number itself. Now, hopefully all of these things are things you've met before and not completely new ideas. Any more prime numbers that you can think of, type them into the chat box. We will go through it in more detail in a moment, but just to test you and make sure that you're paying attention. So a prime number can't be divided by any number except 1 in itself. 3 and 7, perfect, they're prime numbers. Any other suggestions? 2 is also a prime number, good. Anyone think of any other prime numbers that you know of? Bigger one, be brave. 11, 17, 19, oh, perfect. I think every single one of those is a prime number, so very well done. Notice that they're all odd numbers except for 2. 11, 13, 17, good, they're all correct. Well done for leaving out 15. 15 is not a prime number because it can be divided by 3 or it can be divided by 5. So prime number, I mean, it sounds a little bit, well, why do we have to learn about prime numbers? Prime numbers are really what all other numbers are made up of prime numbers, and we'll learn about that. It's called the fundamental theorem of arithmetic. So there's 2 types of whole number, prime numbers and composite numbers. And composite numbers are made up by multiplying prime numbers together. But prime numbers are like the building blocks of all other numbers. So that's why it's quite an important idea in maths. And many mathematicians have devoted the whole of their life to studying prime numbers, if you can believe that. So it's not a trivial thing, it's something that's quite important in maths. There we go. Here's the first 8 prime numbers. Try to learn them, recognise them. I think it's probably as important to recognise which numbers are not prime numbers from this list. So for example, 9 is not a prime number because that's 3 times 3. 15 isn't a prime number because that's 3 times 5. I mentioned that. 21 isn't because that's 3 times 7. So mostly they're odd numbers, but not always, because they can be divided by other things. Okay, and very important, one is not a prime number. Okay, so let's go into a little bit more detail about square numbers. So as I said, that square numbers are found by multiplying a whole number by itself. And the reason it's called squares, if I had 25 little blocks, I could arrange them 5 by 5, 5 rows, 5 columns, 25 blocks. I can arrange them in a square shape. So that's why that's called a square number. Square numbers are really, really important in maths. If you've heard of Pythagoras' theorem, they'll come up there, they'll come up in algebra. You just have to know them, and you need to learn the first 15 squared numbers. Now, most of them you'll know from your times tables. I'm hoping that you know your times tables. I don't really know all of my times tables off by heart, but I know how to work them out. So as long as you do, please don't waste time learning your times tables, but do make sure that you know and recognise these square numbers. Now, the first 10 should be ones that you know. So we've got, these are all square numbers. So 1's a square number, 4 is a square number. 3 times 3, 4 times 4, 16, 5 times 5, 25. Easy. You should know 36, 6 times 6, 49, 7 times 7, 64, 8 times 8, 81, 9 times 9, and quite easy, 10 times 10 is 100. These ones might be a little bit more difficult, but please do try to learn and recognise them. So we've got 11 squared is 121, 12 squared, 144. Now these next two, you might notice a pattern. So there's 169 and 196. So they've got the same digits with the last 2 digits swapped around, so that might help you to remember them. So 169 is 13 squared, and 196 is 14 squared, and the last one, 15 squared, is 225. Now, there is one non-calculator paper for GCSE maths, so you might have to work these out without using a calculator. You might also have to work out the square root of any of these numbers, and what that means, if someone said, I'm just going to rub that out. Well, if someone said, what is the square root of 64, for example? What's the square root of 64? What would it be? Thank you, Sidra. 8, yeah, 8. So square root just means what is the number that I square to get 64? So it's this idea of an inverse operation. We talked briefly about inverse operations last lesson. We talked about adding and subtracting being inverse operations, and multiplying and dividing being inverse operations. Squaring and square rooting are inverse operations. So it's the opposite. How do you get back to where you started? Good. Right, we'll look at that in more detail in a moment. Now, cube numbers. You don't have to learn the first 15 cube numbers because it's very difficult. I don't know any cube numbers above 5 cubed. To get a cube number, you multiply a number by itself and by itself again. So to get 2 cubed, we do 2 times 2 times 2. And that's also written, I don't know if you've met this notation before, this is called index notation, and we will meet this in a lot more detail later on in the course. If you see, so I'm just going to put my pen tool on and try to write neatly. If you see 2 to the power of 3, that means 2 times 2 times 2. Don't confuse it with 2 times 3, because 2 times 3 means something quite different. It means 2 plus 2 plus 2, which is 6. So 2 times 3 is quite different from 2 to the power of 3, which means 2 times 2 times 2. So one is one's multiplying the 2 by itself each time, and the other one is adding the 2 by it. But it's a very common mistake. 2 to the power of 3, or 2 cubed, is 8. 2 times 3, or 2 multiplied by 3, is 6, because you're adding 2 to itself 3 times rather than multiplying it. It's quite different. And we'll go on to powers and indices later on, because it's another very important part of math. You don't need to know everything about it for now. This is just a taster of what we'll be learning about in more detail later on. Now, as I mentioned, for GCSE maths, you need to know all the cube numbers up to 5 cubed. They're quite easy. 1 times 1 times 1, that's easy. 2 times 2 is 4, times 2 is 8. So 2 cubed is 8. Now 3 cubed, 3 times 3 is 9, and 9 times 3 is 27. So 3 cubed is 27. 4 cubed, this is quite an interesting one. 4 times 4 is 16, and then 16 times 4 is 64. Notice, those of you who like looking at patterns, and that's always a good trait in a mathematician, does that number look familiar? Where have you seen that number before? Anyone? It's quite interesting because it's also a square number. What number squared is it? This just happens, there's lots of 8s on my screen, so somebody did say 8. It's also 8 squared, so 4 cubed is the same as 8 squared. If you need index laws, you'll be able to explain why. But so 64 is interesting. So many interesting numbers. 64 is interesting in that it's a square number because it's 8 times 8, and it's also a cube number because it's 4 times 4 times 4. You'd have to learn that. That's just a quite interesting fact. And then we've got 5 cubed. 5 times 5 times 5. 5 times 5 is 25, and 25 times 5 is 125. So if you can't learn these off by heart, you should be able to work them out mentally just using times tables. And then 10 cubed is quite an easy one to remember because it's 10 times 10 times 10. Every time you multiply by 10, you add another 0. 10 times 10, 100, and another 0, 1,000. So 1,000 is also a cube number. So if I ask somebody for the cube root of any of those numbers, you would be able to get back to the original number by recognizing these. Okay, Lewis, yes, 8 times 8. So 4 cubed is the same as 8 times 8. But just from the normal properties of numbers. We'll look at that in more detail when we do indices later on. So here's some questions for you, which you can try now. If you're watching a recorded version, then you can pause this and try them on your own. I'm going to go through the answers now. And if you're watching live and you want to have a go, make sure you tell me which part you're answering so you can write A. So part A is asking me to find the value of 7 squared, or 7 to the power of 2. So can you remember what that is? It means 7 times 7. Thomas, you win. Sidra, I think you've got the first 3 answers there. Let's see if you're right. So to find 7 to the power of 2, or 7 squared, that means 7 times 7. 7 multiplied by 7, not 7 times 2. 7 times 7, you just have to learn it from your times tables, is 49. So 49 is a square number. Now part B, I'm putting in a negative number because why not? And I just want to make a point here because this will come up when you do algebra later on. What happens if we find negative 5 squared? Negative 5 times negative 5. So each lesson I try to build a little bit on things that we've learned before. So we covered this in the first lesson. What do you think minus 5 times minus 5 is? Negative 5 squared. Remember that when you multiply a negative number by another negative number, the minus signs cancel out and the answer is positive. So Joanne, I'm just putting there, Bob and Chamandra, you've all got the right answer. It's just 25. Don't make the mistake of putting negative 25. Now you have to be very careful if you're doing this on a calculator, and I'll show you in a moment why. How about part C? 4 times 4 times 4. So 4 to the power of 3, or 4 cubed, means 4 times 4 times 4. Now 4 times 4 is 16, and 16 times 4. Perfect, 64. Bernice, be careful, it's not 65. It will end in a 4 because the number is. Try to remember that a multiple of 4 will always end in an even number. Okay, so it can't be 65. That's a good check for when you're doing these. So 4 times 4 times 4 is 65. 64. You get me mixed up now. 64. And then the last one. Now be careful with this one. Just glancing down. Fantastic. Everyone who's answered it has done it right. So I put this in to really test your negative number ability. What happens if we cube negative 10? So if we work out negative 10 times negative 10 times negative 10, an interesting thing happens. Now we know that multiplying 2 negative numbers together will give us a positive result. But then if I multiply by another negative number again, it's going to get it back to negative again. So if you find the cube of a negative number, the answer will be negative. Because minus 10 times minus 10, if we do it step by step, gives me 100. There's no minus sign because the minus signs cancel out. And then if I times that by negative 10, then that's going to make the answer negative again. So we've actually got negative 1000. So when you cube a negative number, you get a negative answer. But if you square a negative number, you get a positive answer. And that's a very interesting thing to know. And if I don't want to go into too much depth for people that have just started, but if you had a positive, if you had an even power of a negative number, so if I had -5 to the power of 10, the answer would be positive. But if I had -5 to the power of 11, the answer would be negative. So if you've got an odd number of negative numbers multiplied by themselves, the answer would be negative. But if you had an even number, it would be positive. So that's just quite an interesting thing to, don't learn it, it's just an interesting thing to notice. Now, be very careful when you're squaring negative numbers. If you've got a calculator there with you, unfortunately I didn't bring mine, I want you to use your calculator and I want you to work out -5 squared. So on your calculator, -5 squared, and tell me what your calculator says. So I'm just looking because 3 negative numbers. Why is it different? Do you understand now, Thomas? If you want to watch that bit again, it will make sense, because every time you multiply by a negative number, it switches the sign. So every time you multiply by another negative number, it turns it back to negative. Multiply by another negative, turns it back to positive. Multiply by another negative, turns it back to negative. So it just alternates. If you try a little, jot some questions down, you'll see. So -5, -5. Put it in your calculator and square it. Tell me what your calculator says, if you have your calculator with you. I'll give you a moment to do that if you're watching live. So I just want to say, right, tell me what your calculator says when you put in -5 squared, so -5 to the power of 2. Now on your calculator, you'll probably have a button that says X. It will look like this, X squared, and you can use that to raise a number to the power of 2. Or you can use this button. It might have an X. On some calculators, if you don't have the Casio calculator, it might look like that with an X with a Y, and then you'll have to put in the 2. Or it might look like X with a little square. You could use that button as well, and then put 2 in place of the square to raise it to the power of 2. And there's a bit of a problem here, because we have just worked out a minute ago, didn't we, that -5 squared was 25, because the minus numbers cancel each other out. So Bernice and Christina, you got -25, and your calculator's broken. Joanne, you got 25. What did you do different, Joanne? What do you think? What do you think you did different that meant that you got 25, which is the correct answer, and that Bernice and Christina's calculator gave them the wrong answer? Maybe you can share your secrets to making the calculator give us the right answer. I mean, this is the thing about calculators, is they don't always give you the right answer if you don't put the correct buttons in when you're trying to get there. So what you did was times squared first, then 5. So what we really want is -5 squared. Chamanda, I hope I'm saying your name right. Use brackets. Perfect. That is the answer. You have to use brackets. So notice, I'm just going to go back a slide. Notice that when I wrote -5 squared, I use brackets, and that's to tell me that the minus sign is also being squared. It's not -5 squared, it's -5 squared, if you see what I mean. So when you put a number like that in the calculator, if you type it, oh sorry, that's not come out properly, I meant to put in the keys. I'll save as an image next time. So that should be the keys that you have to press. If you just put it in like this, -5 squared, the calculator will just say -25 like this. Ignore that, it's not displayed the key presses properly in my point to point. But if you put the brackets in like this, that Z there is the minus sign, I think, and that's probably the squared button. But ignore that. So if you put it into the calculator like this with brackets around the minus sign and then square it, that will give you the correct answer. So this is correct and this is wrong. So please use your calculator as you work through the course materials, but you have to be careful sometimes that you're putting the numbers in correctly. You don't have the correct calculator. There's no correct calculator. Any scientific calculator is good for this course. I just use this one because I've got an electronic version, and it's one that's easy to buy in the UK. They're on sale at the moment. If you're watching live and watching this in September, then they're a lot cheaper at the moment. Okay, and I do use this calculator throughout the course material, so if you want to get a copy, you can. If you've already got a calculator, you don't need to buy a new one. It just might work slightly differently. Okie dokie then, square roots. So the square root symbol looks kind of like a tick, and it goes across and above the number like this. Have you seen that before? Square root. Like that. I don't know what I'm drawing again, it's there on the screen. So that's your square root symbol. If it has a little 3 there, that's a cube root. But if it doesn't have a number, then it's just a square root. And we can have bigger bigger nth roots, but we don't worry about that at this level. So that means square root. So let's have a think about what the square root means. So remember, this is a reverse operation. So when I say what is the square root of 16, what I'm asking you is what number multiplied by itself, what number squared gives me 16. Part B, what number multiplied by itself gives me 121. So if you can remember your square numbers from the slide I just showed you. And then part C, what number multiplied by itself gives me 64. And that's called the square root. So what's the square root of 16? So the square root of 16 is 4 squared. So because 16 is 4 squared, 4 times 4, then the square root of 16. Kerry, good. Sidra, right. Katvia, perfect. Thomas, well done. Everyone's got it right. Good. You're fast learners. 4. Now, don't worry if there's people writing things on the screen and you don't know the answer. Learn as you go through. Next one. There's always people that put their hand up and know the answers, but that doesn't mean to say that everybody does. Square root of 121. So what number multiplied by itself gives me 121? Now 121, I remember that that's 11 squared, or 11 times 11. So the square root of 121 is 11. Perfect. Joanne, good, perfect, right. Everyone's got that right. And then the last one, can you remember which number multiplied by itself gives me 64? So you just have to learn them. You'll learn them from your times table. So 64 is 8 squared, or 8 times 8. So the square root of 64 is 8. Perfect. Thomas, good. Joanne and Bernice have all got that right. So 8, good, perfect. Now, here's an interesting question for you. Is there any other number that multiplies by itself to make 64? Because square root of 64 has actually got 2 possible answers. If I said to you, what number multiplied by itself gives me 64? There's 8, and you're too brainy. I thought I'll catch you out and you won't know the answers. But Rob and Paul, well done, good. They've probably done it before, so I don't think they just knew it because they just thought of it. Now, from negative numbers, math is complicated, isn't it? From negative numbers, we know that negative 8 squared minus 8 times minus 8 is also 64, because the minus signs cancel out. So actually, every number has 2 square roots, a positive version and a negative version. Now, this is a little bit beyond grades 1 to 3 that I'm trying to target for the Unit 1 lessons, but I always like to push you a little bit outside of your comfort zones, and this will come up in algebra later on. Now, one thing I will say, very strictly speaking, when you use the square root sign, you're actually only referring to the positive square root. So if you see that square root sign, you only need to write down the positive square root. But there are circumstances in algebra where you might need to write both solutions. If you have something like x squared, where x is a number that I'm trying to find, and if I said x squared equals 49, what is x? Well, in that case, you would have to put both possible values, because x could be 7 and x could also be negative 7. So just bear that in mind. But when we use the square root symbol, we're referring to the positive square root. So here's just an explanation of that. So we've got the negative 8 squared is 64 and positive 8 squared is 64. They're both the square roots of 64. Yeah, I made that point that negative numbers don't have square roots. So somebody tell me why negative numbers don't have square roots, just as a point of interest. So if I said, what's the square root of negative 10? That doesn't have a square root. Why might that be? So remember, when I'm asking for the square root of a number, I'm saying what number multiplied by itself gives me that number. Is it possible to multiply by a number by itself and get a negative number? It's not. Actually, because if you square a negative number, you get a positive number, and if you square a positive number, you also get a positive number. So you can't multiply a number by itself and get a negative result. It's impossible, unless you're a mathematician. You decide to invent imaginary numbers. That's possible, but that's A-level maths. In fact, it's A-level further maths, so don't worry about it. For the purposes of GCSE, negative numbers don't have square roots, so we're not going to use imaginary numbers here, although they're very interesting. So if you're asked to find the square root of a negative number, you just say there is no answer. If you put it on your calculator, it will just say error or something like that. So you can't find the square root of a negative number. Okay, how about I said to you find both square roots of 9? What would they be? So I know that 3 times 3 is 9, but what negative number? Good, yeah. So both square roots of 9, we've got positive square root, which we write like this, and we've got the negative square root, and the negative sign just goes in front of the square root sign just to say. So, okay, good. This is beyond the beginning of the course, but I think it's just all very interesting and gives you a taste for math and why math is really fun and exciting and has got lots of I love it anyway, so I do apologise if I'm going a little bit beyond the scope of what you really need to know. I mean, I could tend to tell you the essentials, but I think going a little bit beyond makes things a little bit more interesting. Okay, cube roots. Before we go, let me just look at the timer. I always talk too much, sorry. Okay, finding the cube root of a number is the opposite of cubing it. So if I say, what is the cube root of 1000? What I'm asking is, what number multiplied by itself and by itself again will give me 1000, or what number cubed will give me 1000? And we use this symbol with a little 3. Yes, 10. Perfect. So you find the cube root. Now, the cube root can be, unlike the squares, you can find cube roots of positive numbers and negative numbers. It works a little bit differently because, as we saw, if you cube a negative number, the answer will be negative. So we can work it both ways. So the cube root of a negative number will be negative, and the cube root of a positive number will be positive. And it only has one answer. It doesn't have two answers like the square roots. So here's some questions for you to practice. What's the cube root of 125? Can you remember that one? What's the cube root of minus 1000? What's the cube root of negative 27? I know I sometimes say minus, sometimes I say negative. And then part D, what's the cube root of 64? See how many of these you can remember before we reveal the answers. 5, good. Negative 10, good for part B. Negative 3, perfect. Bernice, negative 10, that's part B, good. Let's reveal the answers. So 5 cubed is 125, so the cube root of 125 is 5. So we're just reversing it. So because 5 times 5 times 5 is 125, the cube root of 125 is 5. Perfect. Now to get negative 1000, we need to multiply negative 10 by itself. We've looked at that in one of the previous examples. So negative 10 times negative 10 times negative 10 is negative 1000. So the cube root of negative 1000 is negative 10. Good. Everyone got that right. Part C, if we multiplied negative 3 times negative 3 times negative 3, we would get negative 27. So the cube root of negative 27 is negative 3. Perfect. And then the last one, don't mix up 64 with the square root. What number multiplied by itself gives me 64? Well, remember that 4 times 4 times 4 is 64. So the cube root of 64 is 4. Well done. Okay. Now, I want you to do some practice questions. When you go onto the online student community and log onto your course page, there's a good section there, squares, cubes and roots. Just in case you haven't looked at this yet, I'm just going to share my desktop very quickly and show you how to find this. I could give you the link, but I think it's easier for me to show you how to find it. So I'm just going to share my desktop, just so that I can show you how these work, just because it's one of the first times that I've gone through this. I'm going to share my desktop. The screen will just flash briefly for a second. There we go. So here we're logged onto the GCSE Maths course. This is how it looks at the moment. It might look different if you're watching this live in a few years' time, but at the moment this is what it looks like. Go into your GCSE Maths course page. Now you can either scroll down or you can use this menu on the side. So what we're looking for is Unit 1, the basics. So you can click on that there. Or scroll down. This is where you click to access your online textbooks. This is where you click to get the answer books. Hopefully you've done that. This is where you click to watch the lesson recordings on YouTube. And then here is Unit 1, the basics. Now these interactive exercises you can use as you go through the course materials. I'll work through in a similar order. So you've got negative number exercises, which you should have looked at already. The next bit is squares, cubes and roots, which is what we're going to look at now. And then today I'll also cover factors, multiples and primes. So you should be able to do these last two sections after watching this live lesson. So if we go into whole numbers, we'll just click there. It always asks you this if you've already started work on it. I'm just going to say no. Now to go to the bit on squares, cubes and roots, you can just use this menu here. Can you see that on the navigation at the top? Make sure you don't have hide blocks on because then it will disappear. So if you want to go to the bit on squares, cubes and roots, click there. I'll give you that link in the chat box if you want to go straight to it, but I just want to show you where it is. And then go through, answer the questions. So you can see all that one's filled in. I must have filled that in before. So if x is 2, x squared is 4. Check. If x is 3, x squared is 9. Check. So just go through and fill in the numbers. Do you remember what this one is? 196, check. And the squares of the first 10 multiples of 10, have a go at that. Think about what those might be. So 20 times 20 is 400. And so you can go through and check these, but it will go through all the answers here. So if you want to see the answers, press play, and there's a video there which goes through the answers. Similarly with this one. So this is asking you to type in all of the cube numbers, and then all of the answers are shown in the video underneath. Similarly here, work out all of these squares and cube roots, check the answer in the video underneath and go through. If you don't know any of the answers, you can always, on any page, go all the way down to the bottom of the page and click reveal the answers. And then when you go through, notice that all of the answers have been filled in. Now, the system doesn't remember your answers, so you can go through and do this page as many times as you want. You can't go back and then see what the answers are. If you want to show the answers, you'll need to go to the bottom of the page and press reveal. Now, these ones here are quite challenging, but remember that I go through all of them on the calculator using that video, so you can watch that video. So after this lesson's finished, or if you're watching the recorded version, you want to pause and try some of these questions now, then you can. I'm going to stop sharing my screen, hopefully, and then later on when you do factors, multiples and primes, it works in a similar way. There's video solutions there, and if you want to see all the answers, just scroll to the bottom and click reveal answers and you'll see the answers, or you can type them in yourself, so it just makes it a little bit interactive, and you'll see your progress along the bottom. Okay. And you can just use these alongside the textbook. It does have the pages, relevant pages in the textbook there to tell you where you can get extra practice questions if you want them. Stop sharing my desktop. Okay. And another resource that I would recommend, if you go to the Maths Genie page, I will give you the link this time. So if you want to practice square, cubes and roots, I would let me just, the textbook doesn't really cover this because it's kind of what we call pre-GCSE, so it's not really officially in the GCSE course, but it is important and you do need to know it, it will come up. So there's the Maths Genie page. And in the grade 1 to 2 section, there's powers and roots, you download those. Remember, if you click revision, you can watch a short revision video. This will give you some exam style questions and this will give you some solutions. So click on that link if you're watching the YouTube version of this webinar and you can't see the link in the chat box, it won't be active. Click show more on the description box under the video and all of the links will be there. If you are watching the WebEx version of this, make sure the chat box is open. So along the top it says view, click view, open the chat box. This doesn't apply to people watching live. Or click the little red, it'll probably be up that corner, click the little red chat box icon, open up the chat box, click on that link and it will just open up for you. So do powers and roots. Also do the bid math questions. You can do them now because they also involve some questions involving powers and roots. So we did bid math or bod math last lesson, but some practice questions here. This is the practice questions, and this is the solutions, and this is a quick revision video. It's a great website. Okay, let's go on to, so if you want to pause there, try this question if you're watching the recording. The rest of you, I've not got very long left, but I'm just going to go through multiples, lowest common multiples. So we already briefly said a multiple of a number is found by multiplying any number by another whole number. So they're always whole numbers. So for example, 21 and 30 are both multiples of 3 because they're both in the 3 times table. And a common multiple is, so you've got two numbers and you just need to write multiples of both numbers until you find one. It's easier with an example that's a multiple of both of those numbers. So here's two questions for you to try. A, list all multiples of 3 between 13 and 32. So what that is really asking is all of the numbers in the 3 times table between 13 and 32. If you want to have a go, if you're watching live and you want to type them in the box, have a go. And then part B says which of the numbers in the box on the right, so we've got 16, 10, 20, 4, 14, 15, are common multiples of 4 and 5. So that's another way of saying which number or numbers in that box are both multiples of 4 and multiples of 5. So let's have a look at part A. Hopefully you've had a chance to think about it. So we just go through our 3 times table. 4 times 3 is 12, falls outside the range. 5 times 3 is 15, so that would be 1. 6 times 3 is 18, so that would be in the list, and so on. So we'll just list the numbers in the 3 times table. We've got 15, 18, 21, 24, 27, and 30. They're all multiples of 3 between those two numbers. Now for the common multiples, what numbers are multiples of 4? Well, what numbers are in the 4 times table? So 16 is a multiple of 4, 4 is a multiple of 4, 40 is a multiple of 4. What numbers are multiples of 5? I'm going to change the colour. So multiples of 5 always end in 0 and 5, which make it easier. So 10 is a multiple of 5, 20 is a multiple of 5, 40 is a multiple of 5, and 15 is a multiple of 5. The common multiple is the one that is in both. So which one's got a red and a blue box around it? This one, 40. So that's the answer. Happy with that? So those are the, oh, and 20 as well. So I missed one out because 20 can be divided by 5 and it can be divided by 4. Oh, so I was getting carried away. I must have missed that out when I was going through my multiples there. So there's actually 2 common multiples, 20 and 40. But not 15, because 15 is not divisible by 4. If I divided 15 by 4, then I would get, I've got to think now, 3 remainder 3. So 15 isn't in the 4 times table, so that isn't. It's a multiple of 5, but it's not a multiple of 4. Notice that 20 and 40 are both multiples of 20, and 4 times 5 is 20. That often happens, but not always. So if the numbers share a common factor, which we'll look at in a minute, it won't happen, but if they don't, then it will. So that is just, whole numbers are so fascinating. They've got so many properties, they're very, very interesting things. You might say, how on earth could a mathematician spend their whole life studying primes, factors, and multiples? Well, they can. Okay then. Now the lowest common multiple is a very important idea in maths and comes up when we're working with fractions, for example. With fractions, you might hear about the lowest common denominator when you're trying to work with equivalent fractions, which we're going to go on to next lesson. So lowest common multiple is an important idea. And it means the lowest number that both of these numbers divide into. So the easy way to do it, if the numbers are quite small, is to list multiples of both numbers and then see which ones are in both lists. So we've got a few ideas coming up here. 60, well, yep, 12 does go into 60 and 15 does go into 60. But is there a lower number? Is there a lower number that both 12 and 15 divide into? And the only way to really know for sure that there is a more complicated method using products of prime factors, but we're not going to do that until Unit 2. But the easiest way to do it really is just write down the first few multiples of 12, so 12, 24, 36, 48, and so on. Then write down the first few multiples of 15. I know you don't know your 12 and your 15 times table, but you only do the first 5 or 6. There should be plenty, and you can work them out quite easily. The first few multiples of 15, 15, 30, 45, and so on. And then the lowest number in both lists is 60. So everyone that said 60, fantastic. People that are saying 3, you are confusing factors with multiples. So remember, multiples means you multiply the number up. So lowest common multiples will always be bigger than both numbers. Highest common factors, when we do that later on, will be less. So 3 is a number that divides into both 12 and 15, but is different from the multiples. We'll go on to highest common factor in a minute. Can you see the difference? So when I'm asking for the highest common factors will be smaller because they're the divisors, they're the ones that go into the numbers, and multiples will be bigger because we need to multiply up. Got it? So the lowest common multiple is 60. Well done to everyone that said that ages ago. Now here's a kind of problem that might be solved by using lowest common multiples. You might not realise it straight away, but these kind of word problems might come up. So those of you that don't live in the UK, Asda's a supermarket. I don't know if they're supposed to be spelled with capital letters, maybe. So Harry goes to Asda. This is a typical lowest common multiple type word problem. Harry goes to Asda every 4 days. Sounds like when Harry met Sally. And Sally goes to Asda every 6 days. If they both go to Asda on the same day, so one day they go shopping. So today they go shopping in Asda, and then the next time Harry will go is in 4 days. The next time Sally will go is in 6 days, but they'll miss each other. How many days will it be before they both go on the same day again? Now, this will be, you should read this and think, well, that's going to be the lowest common multiple of 4 and 6. That's how it works. If you think about it, if you draw yourself a diagram and say, okay, Sally's going to go on day 4, then she's going to go on day 8, then she's going to go on day 12, and so on, and then Sally is going to go on day 6, and then she's going to go on day 12. So that's the lowest common multiple of those two numbers, and everyone who's typing 12 there, you've got it right. If you can work it out without thinking about lowest common multiples, that's effectively what it is. So if we wrote the multiples of 4, we write the multiples of 4 out like that, multiples of 6 out like that, and then we want the lowest number because that's the next time that they'll both go to the store on the same day. It's 12. So 12 is the smallest number that both 4 and 6 divide into. It's the lowest common multiple of 4 and 6. There's some more examples in the book which you can try later on. So 12 days until they go on the same day again. Okay, now we'll do the other way around, the factors or divisors. So that's the number that divides into the number exactly without leaving a remainder. Now, I mentioned briefly at the start, to find factors of a number, we think of pairs of numbers that multiply together to make that number. Now, a number is a factor of a number if it divides into it exactly without leaving a remainder. So 6 is a factor of 18 because 18 divided by 6 is 3. And 3 is also a factor of 18 because 18 divided by 3 is 6. And then remember, you've also got 1 in the number itself. But 5 is not a factor of 18. Because if I divide 18 by 5, I get a remainder. It's not a whole number, so it's not a factor. It has to divide into it exactly without leaving a remainder. And if I was asked to find all of the factors, the easiest way to do it is to think of pairs of numbers that multiply together to make that number. So if I was asked to write down all the factors of 24 from smallest to greatest, to make sure that I don't miss any out, you work in a kind of a systematic way. The first thing to do would be to say, well, I know that 1 times 24 makes 24. So 1 and 24 are both factors. So I would start by writing 1 times 24. So 1 and 24 are both factors. And then I would say, okay, how about 2 times something? Can I do 2 times something to get 24? Well, I can do 2 times 12. So that means 2 is a factor, and 12 is also a factor, that both those numbers both divide into 24 exactly without leaving remainders. Sidra, you've already got a big long list there. We'll see if you're right in a moment. How about 3? Does 3 go into 24? 24 does have a lot of factors. Yes, it does. How many times? Well, 3 times 8 is 24. So we can write 3 times 8, and that means 3 is a factor, and also 8 is a factor. Okay, next number 4. Can I do 4 times something to get 24? Well, yes, 4 times 6 is 24. You know your times tables. So both 4 and 6 are factors of 24. How about 5? Can I do 5 times something to get 24? No, because 5 doesn't divide into 24, so that means that 5 isn't a factor. Can I do 6 times something? Well, I can do 6 times 4, but I've already got 6 and 4, so I can stop there. So once I get to a repeat at 7, 8, 9, I'm just going to go back the other way again. So now I've got all my factors, and I can write them in order like this. 1, 2, 3, 4, 6, 8, 12, 24. And those are all of the factors of 24. And I write them in a list like that. Perfect. Yep. I think, Kerry, you've got them all right, but just not quite. So it just says from smallest, put them in order, but they're the right number, so that's the main thing. They almost always go in pairs. Well, they always go in pairs, but if you have a square number, then there might be an odd number of factors rather than an even number of factors. I'll let you do that as a separate exercise. Not the right order. Yeah, no, of course, that's fine. It doesn't matter about the order so much. Right, now we look at common factors. Almost at the end, almost at my 1 hour mark, sorry. So sorry if I go over a little bit. I know last lesson was well over, but I'll try to keep to my 1 hour slot. So a common factor of 2 numbers is a factor of both of those numbers, as we've discussed briefly before. So write down the common factors of 16 and 20. So what are any numbers that go into both 16 and 20? The easiest way to do this probably, 2 and 4 do both go into 16 and 20. What about 1? What 1 is a common factor of all numbers? So 16, we find the factors of 16. 1 times 16, 2 times 8, and 4 times 4. So the factors of 16 are 1, 2, 4, 8, and 16. And then the factors of 20, I just do it the long way, so we've got 1 times 20, 2 times 10, and 4 times 5. So the factors of 20 are 1, 2, 4, 5, 10, 20. I'm just going forwards and backwards to put them in order. And then we want the common factors. So which numbers are on both lists? Well, we've got 1 on both lists, we've got 2 in both lists, and we've got 4 in both lists. So those are our common factors. There we go. Both numbers are both appear on both lists. Perfect. What's the highest common factor? So this is a little bit different. What's the highest common factor of 16 and 20? So we're going to do highest common factors. That's important. 4. So it's just the highest number that's in both lists. There we go. So highest common factor is the highest number that divides exactly into both numbers. So if I asked you to find the highest common factor of 12 and 18, you would just write down the factors of 12, the factors of 18, and then the highest number that goes into both. Chamandra, be careful if you get, it's easy at the beginning to mix up lowest common multiples and highest common factors. Highest common factors is the numbers that divide into the number that divises. So the highest common factor will be the highest number that's in both those lists, which is, there's all of the common factors, highest common factor, 6. Perfect to everyone. No, don't apologise. It's important to say that because a lot of people will make that same mistake. So at least that will reassure them to know that I've got those mixed up. Making mistakes is a really important part of learning. So don't worry about it at all. You're more likely to remember it now once you've got it wrong once. Okay, so highest common factor will always be, because it's got highest in front of it, but it will always be a smaller number, and lowest common multiple will always be a bigger number. But that's the way it goes. So the highest common factor is 6. Now, just one last thing, and I'm going to go over time, I think, because I want to show you how to write numbers as products of prime factors. Now, we met prime numbers already, so I'm going to go through this slide quite quickly. A prime number is a whole number greater than 1, so it doesn't include 1, whose only factors are 1 and the number itself. So we met that briefly before. So the first 8 prime numbers, which I introduced at the start of the lesson, we don't include 1. That's not a prime number. First 8 prime numbers are 2, 3, we've got 5, 7, so 3, 5, 7, odd numbers. Be very careful, 9 is not a prime number because it's divisible by 3, so the next prime number is 11. 13, 15 is not a prime number, so now we're just looking at odd numbers. 15 is not prime because it's divisible by 3 and 5. 17. How about 19? Yes. No numbers divide into 19 except 19 and 1. So these are the first 8 prime numbers. Try to learn them and be familiar with them. I mean, I would even learn 23 and 29 because, especially when you're writing numbers as products of prime factors, you need to know the prime numbers. Learn them. Now, I'm very quickly going to introduce this, but it's a topic that I will go back to later on in Unit 2. So if you want to skip products of prime factors for now, you can. But I'll introduce it briefly now for those of you that want to go through a little bit more quickly. But I will definitely come back to this later on, so don't worry about it too much. So this is what's called the fundamental theorem of arithmetic. And what I mentioned earlier is that all whole numbers can be made up of these building blocks called prime numbers. And what I mean by building blocks is I can always multiply any prime numbers together multiplied to make other numbers, composite numbers. I'll show you what I mean by that. So we think of breaking numbers up into their prime factors. So the product of a group of numbers means the numbers multiply together. So product means, so 2 times 2 is a product of 2, and that makes 4. So we can write numbers as products of prime factors, and what that means is prime numbers multiplied together to make that number. So here's a number, 40, and we're asked to write it as a product of prime factors. So the way we do this is we break the number up. And there's a couple of ways of doing it. Factor trees are lovely, so you can use a factor tree, or you could just break the number up step by step until you can't break the number up anymore. So for example, if we split the number up step by step, so we've got 40, and all you have to do is think of any 2 numbers that multiply together to make 40. It's better to think of a prime number, so we've got 2. 2 times 20. Now, 2 can't be broken up because it's a prime number, so I can't, and we're not including 1 because 1's not a prime number. So 2 is a prime number, so I've got a prime number, that's what I wanted. But then I've got 20, and 20 can be broken up. So any 2 numbers that multiply together to make 20, it's better to think of a prime number, but it doesn't have to be. It could be 5 times 4, or it could be 2 times 10. So we're going to split that up into 2 numbers. So we've got our 2 there. So 20 is 2 times 10. 2 is a prime number, so that's good. We're happy with that. How can we break up 10? 10 is not a prime number. Well, just break it up into 2 numbers. So 2 times 5, or 5 times 2. Perfect, good. Oh, Sidra, you're way ahead. 2 cubed times 5. You're right. So we break up 10, and 10 is 2 times 5. So that's the answer. The prime factorization, or the product of prime factors for 40 is 2 times 2 times 2 times 5. And if you want to write it using index notation, you can. Index notation is just writing it as a power. You can write it as 2 to the power of 3 times 5 in index form. It's just a more concise way of writing it, so you don't have lots and lots of 2s. And any number can be written like this. Any whole number can be written like this as product prime factors. If the number is already prime, then it's just a number. So obviously, any composite number, any non-prime number can be written as a product of prime factors. And this comes up when we're trying to find the lowest common multiple and highest common factor of more complex numbers and more difficult examples. But don't worry about that for now, because you can go onto it if you want to. I'll show you where to find it. But for now, just stick to this. And this is how you do it with a factor tree. So with a factor tree, you write the number at the top of the tree, and then you just split it up into any 2 numbers. So we could use 10 and 4, we could use 2 and 20. I'm going to use 5 and 8. That's as good as any 2 numbers. If either of the 2 numbers are prime numbers, then you draw a circle around it. So 5 can't be split up, so I draw a circle around it. But 8 can be split up. 8 can be split up into 2 times 4, or it could be split up into, well, just 2 times 4, or, yeah, 2 times 4. I think that's the only way you can split it up. So we'll split it up into 2 times 4. You can include 1. That's the big rule for this, though, because that would just send you around in circles. So we can split it up into 2 times 4, circle the prime number, and we've got 4. 4 is 2 times 2, so we split that up, and we've got 2 times 2. And then all the numbers that are circled, we get exactly the same answer as before, 2 times 2 times 2 times 5. So that's the prime factor form of 40. Now I'm going to stop there. There's lots and lots of practice questions, and I'm going to send you some links to some videos. So if you want some more examples of this, I'm coming to the end of my 1 hour. Hegarty Math has got some really good videos which you can use to practice this. So I'm just going to link you to these Hegarty Math videos. Now you might need to set up a Hegarty Math account first for these links to work. Their website is mathswebsite.com. So set up a website, an account there if you haven't done so already. That's the link. If you can't see this link, remember YouTube videos, click show more under the video, turn on the chat box if you haven't. Oh, that link's not hyperlinked, I don't think it's, oh, it's because I haven't put the, if you Google that anyway, it'll work out. It's not come up as a hyperlink. Sorry about that, I should have hyperlinked it. Let me just find the actual hyperlink so that you can just click on that. I know it's not a link, so it's not blue. Oh, thank you. Someone's done it for me there already, but if you just click on that, it will take you straight to the website. Now, here's the links for the actual videos. So this will be in the GCSE section. So if you're having trouble with any of these links, in fact, somebody watching live might just test one of them and let me know if they're working. You might need to log in first, so you'll need to log in or register free from an account, and then you should be able to click on those videos and they should open up. If not, just go into the GCSE section, click on Foundation, then click on Number, and you'll be able to see all of these videos in a long list. So there's some excellent video examples there, Hegarty Math, it's really good. Don't forget you've got your Factors, Multiples and Primes section on your ICS Learn Student Community. There's also videos on there, as I showed you, so you can go through, and there's lots more examples of using factor trees. Go through and watch those videos if you want more practice questions and fill in those. The links work fantastic. And then there's also a section in the digital textbook. So I've not done chapter 2 and 3 yet. I'm not following it in order, as I said. So if you want some more practice questions, chapter 4. In the Foundation tier book, do all of exercise 4A. You should be able to answer all of those questions. It's just general questions about prime factors and multiples. Exercise 4C, that's about prime numbers. Do questions 1 to 3. And in exercise 4D, do questions 1 and 2. Leave out question 3 for now, because I'm going to go back to how to use prime factor. Yeah, you can read up on it on the book and do that question if you want to, but I'm not going to go through that until Unit 2. And try 4 and 6. If you are finding these too easy and you want a challenge, then try the questions in the higher tier book. There's some more challenge, very, very similar. Most of the questions are the same, but there's some more challenging questions in the higher tier book. I'm just going to give you a link to the actual chapter 4 in the textbook. Don't worry about the section on place value, because I'm going to go on to place value when I do decimals in lesson 6. So here is a link to the chapter in the Foundation tier book. So that will take you straight to 4. Even if you plan to do higher tier later on, just do the foundation tier book for now, because it's kind of the same in both books, it's just repeated. And then if you want to do a little bit more and go ahead in the course, then you can do lesson 17, which I recorded last year. So this will take you to the, let me just show you which one this is. So this is, no, never mind. I did it on another slide, but I'll show you in a second. So that link takes you to a recorded version of lesson 17, which goes into prime factors and multiples in a lot more detail. So if you want to move ahead and this is too easy, skip to the lesson 17, and you can read up on it there, and then you should probably be able to do most of those exercises, exercise 4D. If the textbook is really too hard and you want something a little bit simpler, then you can use this foundation workbook. I gave you a link at the beginning of the lesson, but I'll give it to you again just in case. Now, I saw these quite cheap if you buy them used on Amazon, and it just has practice questions for everything in foundation tier, everything up to a grade 5, old GCSE, lower grade B. It doesn't have explanations of any of the topics, but if you use this alongside my online lessons, you should be able to cover everything that way if the textbook is a bit tricky. Okay, so you can go do those pages. Maths Genie, as before, factors and multiples is in the grade 1 to 2 section. So the Maths Genie page is there. I'll give you a link just now. So Maths Genie, I've got it in another page here. So this is a link to Maths Genie if you just want to click on that. So if you click in the chat box, it should just bring open in another window. Factors and multiples, there's a revision video. There's some questions. These are quite easy questions and some solutions. If you want some more challenging ones, lowest common multiple and highest common factor is actually in the grade 4 section. So if you want to try those, lowest common multiple and highest common factor, you can try them if you want. There's a revision video, there's a worksheet, and there's some written solutions. So these are exam style questions. So if you just want to go straight to the kind of things that might come up in the exam. The new GCSE 9-1 questions might be a little bit trickier, but these are good practice anyway. They're set out so you just write the answers on the paper, so use them. And that's about it. If you want to jump ahead and do some more in-depth work on factors, multiples and primes, then you can just open up the ICS Land Study Plan or go to the GCSE Math lesson page and watch lesson 17. If not, just stop there and you can revise it and revisit it later on when you go on to Unit 2. Okay, that's it from me for today. Next lesson, I'm going to go on to equivalent fractions. I'm going to show you how to write equivalent fractions using lowest common denominators, how to compare fractions, how to add and subtract fractions. I know a lot of people have a bit of a fear of fractions, but really they're okay. And I'm not going to go beyond just normal fractions. I'm not going to do mixed numbers or anything like that just yet. So we'll just introduce you to writing equivalent fractions, really important in maths. That's about it from me for today. Hope to see you next lesson. If you're watching live, next lesson will be on Thursday next week. So hope to see you then. Are there any questions before I let you go? If you do think of anything or you're working through the exercises and you need a bit of extra help, click on the Contact Your Tutor box. You can ask your tutor for help at any time. You can ask me as well if it's something that your tutor might not know about or something to do with the lessons, then feel free to ask me for help as well. If you enjoyed this lesson and would like to encourage, some people don't like the idea of coming to live lessons, but you know, I think it's a really good way to learn, and if you would like to encourage more students to come along and watch the lessons, even if you're watching the recorded version, feel free to head over to Trustpilot, leave me a review, mention my name, that would be great, and hope you're enjoying the course so far. Here's all our contact details. Student services phone number is there if it's anything that's not maths related. Also remember that you've got the discussion forum so you can chat to other students. So use Ask a Maths Teacher and I will answer those questions, talk to other students. If it's a math question, I usually answer it there as well, but if you want to chat to other people and see how everyone else is getting on, you can use that. And use exam discussion for exam-specific questions. There's also some mock exam papers on there on the exam discussion if you want to have a look at them. That's all from me for today. Thank you very much. And, sorry, thank you very much. I just thought somebody asked me a question there. Thank you very much. I hope all of that was okay, and I will see you next lesson. Bye-bye.